Okay, this video will go over logarithm test review. So the first one is to graph your domain, your range. This is a vertical asymptote, and we've been using the graphing calculator to get this done. So as you can see, you have to type it in a certain way. Make sure you close your parentheses. I did log x divided by log 3, but then I multiplied by 3 out front. The reason I know where to put the x is our change of base formula. Is you take the base of the log, you put that on the bottom, so log of a is on the bottom, and then you take whatever it's of and you put that on the top. So the change of base formula looks like that. So when you go to type this in your calculator, you have to do y equals log of x divided by log of 3. Okay, and then you need to take all of that and times it by 3, because that's 3 log 3 of x. All right, your range is always all reals, and we'll talk about that in a second. So the other thing that's nice about the calculator is you do second graph, it gives you full points, and you can plot. I need points on the graph. So 1 0 3 3. You look your cursor down. 9 6 is another full point. And we know that this thing, once it gets past this point right here, it dive bombs. All right. After 0, we get an error in our calculator. That's telling us that there's this restriction. The other way you can look for your vertical asymptote is look at this part right here and set it equal to 0. Well, if that's just x equals 0. Okay, so that's my restriction on x right there. So that's going to affect my domain. Okay, domain is only going to go from 0 over to infinity. All right, now my range, this is going to increase forever, and it's also going to decrease. This thing's decreasing very quickly. So this is all reals, or you can write negative infinity to positive infinity. Don't forget this change of base formula, because the very next thing, when we go to evaluate a log, if we have log base a of b, to evaluate that, I can just do log b over log a. Okay, so in this case right here, now you can turn this into an exponential. You can say, hey, 2 to some power equals 1 over 36. But this one's not real intuitive, so I would just go straight to change of base. So you do log of 1 over 36 over log of 2. And when you press enter, you get negative 5.17, and it rounds out to zeros there. Now, why this is so important is because think about this. 2 to the negative 5th, all right, that's what this is saying. X is equal to negative 5. So if I just think about something that's close to that, 2 to the negative 5th, 2 to the negative 5th is 1 over 2 to the 5th, or 1 over 32. So you can see how 5.17 would make it up to 36. So writing it as an exponential can help you think about whether your answer is correct or not. So the answer for that one is negative 5.17. Okay, same thing with this one. This is saying 81 to some unknown power, if you set this equal to x, equals 9. And you might even be able to just think through that and think what x equals. But if you can't, then you can always just do log 9 over log 81 in your calculator. Make sure when you plug it in your calculator, you put parentheses around the log 9. I can show you here. So when you go to log 9, close your parentheses, divided by log 81, press enter, and you get 0.5. So that's 1/2. All right. You can also think about this as the square root. The square root of 81, guess what, is 9. So it checks out. All right, so this one's saying 3 to some power is 10. All right, if you know what a log stands for. Well, 3 squared is 9, So I know x is it's greater than 2, but it's like 2.1, somewhere around there. Take the guesswork out of it. Just do log 10 divided by log 3, and you get 2.0959. See, so my guess, 2.1, if I would have rounded to the nearest tenth, would have been right. Number 6, real quick, this is 4 to some power equals 64, and guess what? That's a perfect one. 4 to the third power, see, 64 equals 4 to the third power, so x equals 3 in this point. So some of them come out whole numbers, and you can just think about them. Okay, now when we have an x within the problem, okay, we have to set up an equation, and we have to turn this into an exponential equation. So that all comes back to this. If we have log base a of b equals x, okay, that converts to a to the x equals b. So I've said this several times in class, the base of the log is the base of your exponent. And then it kind of feels like the x and the b switch spots. Okay, so this is this is 3 to the 5th power equals x. The base of the log became the base of my exponent. This is my exponent, and then x comes out front. And this is as simple as doing 3 to the 5th in my calculator, and I get 243 equals x. That's my answer. Okay, this one here, this one's saying x, that's the base of my exponent. The 3 is the exponent. So something to the 3rd power is 343. Well, you can use your algebra skills here. How do you undo a cube? You cube root it. And guess what? The cube root of 343 is just 7. You could guess and check there too. What number cubed is 343? All right, when you have logs that are the same base, you can go ahead and drop those logs, and you have yourself just an equation, like that. Set them equal to each other, and if it's a quadratic, get one of the sides equal to 0. It's easiest just to bring those over by doing the opposites. Looks like that's going to be plus 5x. You're going to bring the 4 over by adding 4. So I'm just solving a quadratic like I know how. I'm going to solve this one with factoring. You could use the quadratic formula if you want. But those are two things that multiply to 4 and add to 5. So it looks like my answers are x equals -4 and x equals -1. We want to check those. We want to plug them back in and make sure, because we had this rule in a logarithm, b must be greater than 0. Okay, if not, it's undefined. So we plug them back in, and negative times a negative is going to be a positive there. -4 is we're good. So both of these check out. So they're both good answers. We don't have to eliminate one of them. Okay, this one was a little hard to see on your original paper, but just stick with what you have. I know this is an expression in here, but what is this saying? This is saying 4 to the 4th power equals x plus 3. If you just think about that, that's not that hard of a problem, because 4 to the 4th is 256. And obviously, I don't even need to subtract the 3. 253 plus 3 gives me the 256. All right, this one is just saying 16 to the x power equals 4. So 16 to some power is 4. If I remember, the square root of 16 is 4. How do I write the square root of 16? It's 1/2. So if you were good at those, you're good. If not, really this is just an evaluate. This is like problems 3 through 10. I have the base, I have the of part, I'm just looking for the equals part. So you could use the change of base formulas also, but hopefully you see this as, you could do this, that this is 4 squared to the x, and this is, this is just 4 to the 1st. So if you did a power to power, you get 2x equals 1, and you just solve that with an exponential equation, you get x equals 1/2. Okay, but back to you just using the evaluate part, I should be able to just do log 4 over log 16 and get an answer, and that will give me 1/2. So you have everything you need to find x. This is really just an evaluate problem. Okay, down here I show this one, not that it's different, but I have log 5 and log 5, so log base 5, logs are the same, I can cross those out. So x squared equals 121. How do I solve a log, or solve a quadratic with just a quadratic term? I square root both sides. So x equals, now the square root of 121 is positive and negative 11. Those will both work in this situation, so you want both of those. Okay, 21, not that it's that much harder, but we have two of the same logs, so those cancel out, and we have a quadratic that we have to solve, and I'm gonna bring both of these over by subtracting them away. This one just comes over, so I get 2x squared minus 3x minus 20 equals 0. Once you're at this point, you just factor, and this is not that difficult to factor. You got to think of two things that multiply to negative 20, but they're going to add to negative 3. We got to keep this 2 in mind. Okay, so I'm thinking 5 and 4 I want to start with, just because they're kind of close together. And if I make this a negative 10, when I factor these, when I multiply these two, that's negative 10, and I add 4 to it, that's not going to quite work, right? So so you switch spots, all right? Maybe the 5 needs to go here and the 4 needs to go here. Sorry, minus 4 here. So I think about that, and I do 2 times negative 4, that's negative 8, plus 5. Negative 8 plus 5 is the negative 3. So my combination that works, let me rewrite it so it looks a little better. So my combination that works is right there. Zero product rule. Set these both equal to 0. This one's real easy. That's 4. This one you would subtract 5, then divide by 2, so you get negative 5/2. Check both of those. You plug them both back in. You end up with positive answers. So or positive logs. So you're good to go. They're both good answers. All right, 2 more real quick. Number 22. This is, look, it's opposite. It's an exponential equation, but you have to use logs to solve it. All right, so remember, if we're going a to the x equals b, the base of the exponent becomes the base of your log. All right, and then that equals x. All right, so here we go. This is log 4. The base of my exponent becomes the base of my log. The 20 is here and the x is there. So really, this is exactly like question number 17, if you think about it. If you look at number 17 here, you have log base 16(4) equals x. Well, I have log 4 of 20 equals x. So all I have to do is do my change of base. Log of 20 over log of 4 equals x. And when I do that, I get a decimal. So you're expecting decimals here for number 22. So you get x equals 2.1610 to the nearest 10,000ths. Last one here, same thing. We're going to turn this into a log. So you have log base 4 equals of 15 equals the 2x minus 5. So there's really not much difference between 22 and 23, except on this side now I have 2x minus 5. All right, well, how do I find the decimal for that? Change of base. You do log of 15 over log of 4. That's going to equal 2x minus 5. Again, that is just a decimal. So don't overthink this. This is 1.9534. and we're going to, solve this two-step equation. We're going to add 5. So that'd be 6.9534, then divide by 2. X equals 3.4767. And finally, I'm going to try to reveal the answers for all of the questions, not just the ones I showed. So there's those. You can pause the video if I'm going too fast. All the circled ones are my answers, so hopefully you can read those. Okay, hopefully you look at it, study, and do well on the test tomorrow.